Hey, we just completed finding volume using a disk method, which disk could be several coins stacked on top of each other or something like that. But now we're going to look at the washer method, which is not much different, but it does have one little attribute, and that is that the washer is for when you leave a gap in something. So just kind of by definition, a disk looks like a circular region. Okay. But a washer, kind of like a nut and bolt washer, would have a hole in the middle. Okay. So we're talking about taking a region that when we rotate it around some line would leave some type of gap or blank area or space in between. So what that means is for all of our figures, when we rotate them, there will be an outer radius going out to the outside of the figure, and we'll call that big R. And then there will be a smaller radius going to the inside of the washer, and that would be a little r. So the idea is that if we use the far radius, the outer radius, we would find the whole disk, but then if we do use the inner radius, we would find the piece that we want to subtract out of it and see what is left. Okay? So that's the idea. We're going to have an outer radius, which would give us the whole disk, and then an inner radius, which we could subtract out the part where we want to leave the hole. So again, we have an outside radius for a big R, and we have an inside radius for a little r, and that's all in perspective. So taking a two-dimensional region of area and spinning it around the x-axis can create this washer, and that effect would give us the formula integration from a to b of pi. That'd be times the outer radius squared minus the inner radius squared, and if we're going around an x-axis or something parallel to the x-axis, we'll use that all in terms of x, so dx. If we want to take a region of area space and spin it around the y-axis or something parallel to the y-axis, then we're going to do the same thing, but we want everything in terms of y. So again, integration from a to b of pi times the outer radius squared minus the inner radius squared dy, so everything will be in terms of y. Okay? So just like the disk method, the direction you go, you use that variable. So let's see here. We're going to find the volume by rotating the graph we have here around the x-axis. So we're going to go around the x-axis. You can imagine what this is going to look like. It's the region where the outer radius, from looking at the picture, the outer radius is 1, y equals 1, and the inner radius, okay, is y equals the square root of the cosine of x. And we've got the region in between there, so we've got the region between a straight line and a curve. And we're going to run that from negative pi over 2 to positive pi over 2. So let's set that up. Since we're going around the x-axis, everything is going to be in terms of x. So volume equals the integration from, in this case, negative pi over 2 to positive pi over 2. We're going to put our pi on the outside like we did with the washer. So the outer radius is 1, so that'll be 1 squared, minus the inner radius, which is the square root of cosine of x. That'll also be squared, and it'll be integrated dx in terms of x. So just cleaning that statement up a little bit to get rid of the squares, we got pi integral negative pi over 2 to pi over 2, that's my bounds, of 1 minus cosine of x dx, which is pretty easy to integrate. Pi, the constant stays on the outside. The integral of 1 is x, and the integral of negative cosine is negative sine of x. So that'll still be run from negative pi over 2 to positive pi over 2. So we've got the antiderivative, and we know what we want to integrate with our bounds. So let's start plugging things in. So we'll let x equal pi over 2. So that'll give me pi times pi over 2 minus the sine of pi over 2. And then we're going to subtract off and letting x equal negative pi over 2. A little messy there. But that'll be pi times negative pi over 2 minus the sine of negative pi over 2. So a couple of things here. The sine of pi over 2 is 1. So in the first statement, when I distribute, when I distribute my pi through, I will have pi squared over 2 minus pi. And then the second part, the sine of negative pi over 2 is negative 1. So when I distribute negative pi times negative pi over 2, I will have positive, pi squared, pi squared over 2. And then negative pi times negative negative 1, so that's 3 negatives, so that'll be minus pi. So everything comes together as pi squared over 2 plus pi squared over 2. That'll give me 2 pi squared over 2, or pi squared. And then negative pi will give me negative 2 pi. So that's an exact volume here. Pi squared minus 2 pi. If for some reason we want to see what that looks like in a calculator, plug it in, I get about 3.586. Okay. But the idea was here that going out to the radius of 1 would give us a solid, kind of like a cylinder when we rotate this thing. And then we would take out the curve on the inside when we rotate it. Okay. Let's stop there and we will do our next examples separately.